Hello viewers, you're welcome to my YouTube video. Today I will solve a problem that will explain some of the measures of dispersion and the coefficients of variation. I'll read out the question. In an apple eating competition, the number of apples eaten by 5 contestants in 15 minutes is as follows: 8, 10, 7, 12, and then 11. Use the above data to calculate the mean, the variance and standard deviation, coefficient of standard deviation, and coefficient of variation. To solve this problem, as usual, I'll pull out my table. Okay, my table. The first column, I'll give it a name X, right? I'll use the letter X to stand for the first column. And then I'll fill it up with the values representing the amount of apples consumed by the 5 contestants in 15 minutes. So I'll arrange the values in ascending order. The first one is 7, followed by 8, and then I have 10, 11, and 12. The next thing to do is to sum up this column, because I don't have any contestant that eats more than once, so they just have the opportunity of eating once within the span of 15 minutes. So had it been we have 2 contestants that ate 7, 7 or something of that nature, in a nutshell, I don't have a frequency column. The frequencies, each of the data occur once, so I don't need to have a column for frequency. So all I need to do is to sum up the content of the first column. So 7 plus 8 plus 10 plus 11 plus 12 equals 48. That's summation of x. The next column will be the deviation, x minus x bar. Now I have a challenge. I need to find the mean, which is x bar. So let x bar be equal to mean. X bar equals summation of x divided by n. This is for an ungrouped data. As you can see, this data is not grouped. X bar equals, the summation of x is 48, and 5 contestants took part in the competition, so n is 5. The mean will now be equal to 9.6. okay, 9.6. That's the mean of the values given to us here. Now with that, I can fill up the first column. You can see, the second column, the first cell under the second column. So I know you're wondering how I got minus 2.6. All I did was to find a difference between 7 and 9.8. So 7 minus 9.8 equals minus 2.6. 8 minus 9.6 equals minus 1.6. 10 minus 9.6 equals 0.4. 11 minus 9.6 equals 1.4. And then 12 minus 9.6 equals 2.4. Now I don't need to sum up this column, but all I need to do is to find the square of this deviation. So the square of the deviation, x minus x bar, everything to the power of 2. So minus 2.6 times minus 2.6 equals 6.76. Minus 1.6 times minus 1.6 equals 2.56. 0.4 square equals 0.16. 1.4 square is same as 1.96. 2.4 square equals 5.76. Now I need to sum up this column. So 6.76 plus 2.56 plus 0.16 plus 1.96 plus 5.76 equals 17.19. That's the summation of this column. I know you'll be wondering, why did I have to go through this route rather than finding the absolute value? The reason is because I need to find the variance and the standard deviation. In a short while, I'm going to show you the formula for finding the variance and the standard deviation, but I needed to get values for these 2 columns, as the summation of this column will be instrumental in me getting the value of the variance and the standard deviation. Okay, so the second value, I would say let my variance be equal to v, let v be the variance, and let s be the standard deviation. Okay, so the variance will now be equal to the summation of x minus x bar all square. That was the or rather that's the summation of the third column, which is 17.19, divided by the number of participants in the competition. Five persons took part in the competition. Okay, now that I have my formula and all the parameters available, now for the standard deviation, it will be equal to summation of the square root of summation x minus x bar whole square over n. Now you can see that there's a relationship between the standard deviation and the variance. And what is the relationship? The variance, the square root of the variance is equal to the standard deviation. So if you have a variance and you don't have standard deviation, all you need to do is to find the square root of the variance. In situation where you don't have the variance but you have the standard deviation, how do you get the variance? Just square the standard deviation. The square of the standard deviation will be equal to the variance. Okay, so I will find the variance first. So variance will now be equal to, already I have the numerator, which is 17.19, divided by the denominator signifies the number of participants in the competition, which is 5. So variance equals 3.438. Therefore, the variance will be approximately equal to 3.44. So I just wanted my answer not to be more than to 2 decimal places. Okay, this one gave me 9.6, so I needed not to add 0, but if you feel like you can add 0 to it, we're not constrained by the question to approximate to any significant, to any decimal place. So anyhow you leave it is still okay. I just decided I wanted it to be 2 decimal places, sorry. Okay, now for the standard deviation, it will be the square root of the variance. Okay, standard deviation will now be square root of the variance, so I would rather use the value before the approximation. The reason is because if I use this value, it will minimize my error. If I use the approximate value, it will make the error to be bigger. Okay, so I will not want my error to be bigger. I want to minimize my error in solving mathematical problems. Standard deviation will now be equal to 1.854 when you find the square root of 3.438. Therefore, the standard deviation for the purpose of uniformity to 2 decimal places will be 1.85. Now, I know you'll be wondering why this one was 3.44. Here it was 3.438. Some people will be wondering why is this last digit not 3? The reason is because 8 is more than 5, so I'll round it up, it becomes 1, and I'll add it to 3, and that will make it 3.44. Here, the third digit after the decimal is less than 5, so I'll round it down, it becomes 0. So my answer will be 1.85. Okay? Now to the third part of the question, coefficient of standard deviation. The coefficient of standard deviation. I will say let the coefficient of standard deviation be CSD. Okay? Now the coefficient of standard deviation equals the ratio of the standard deviation to the mean. Ratio of standard deviation to the mean. Already I've gotten my standard deviation as 1.845 or 1.85 as the case may be, and then my mean is 9.6. All I need to do is to plug it in. So coefficient of standard deviation equals 1.854. You know, I mentioned earlier that if you have to use previous answers to solve a problem to get subsequent answers, it's better to make use of the value before the approximation. So I would rather use this than this. Divided by the mean is 9.6. Okay, coefficient of standard deviation will now be equal to 0.193. For the purpose of uniformity, the coefficient of standard deviation will be approximately equal to 0.19. Okay, the third digit after the decimal is less than 5, so I'll round it down, it becomes 0. And this is my coefficient of standard deviation. So I'm done with the third part of the question. I'll move to the last part of the question, which is the fourth part. Let the coefficient of variation be CV. Now, the coefficient of variation is similar to the coefficient of standard deviation, just that you see the difference now. Standard deviation divided by the mean multiplied by 100%. So the difference is that in the coefficient of variation, you have to multiply your answer by 100%. Okay? So already we know our standard deviation as 1.854 divided by the mean 9.6 multiplied by 100%. The coefficient of variation will now be equal to 19.3125. 19.3125. Now I have my decimal values to, the answer is to 4 decimal places. Therefore, I'll approximate it to 2 decimal places to be 19.31. 2 is less than 5, so I'll round it down. So everything after from 2 to the right becomes 0. So I'll have 19.31. So this is the coefficient of variation. Now, as you can see, this problem has been able to help us to understand how to find two of the measures of dispersion, which is the variance and the standard deviation, and then the coefficient of variation coupled with the coefficient of standard deviation. Okay, so I hope you understood the problem that I've solved. If you have any comments, kindly drop it at the comment section. And if you have not subscribed to my YouTube channel, the name again is Victorian STEM. Rather, the name is Victorian STEM. Okay, hit the subscribe button, the subscription button, and I will appreciate it. Thank you for watching my YouTube video. Bye bye.